Let's consider the following scenario. A metal tank begins filling with water. Now, the weight of water and the tank vary at a constant rate of change of 8.35 pounds per gallon with respect to the volume of water in the tank. We'll let the variable V represent the volume of water in the tank in gallons, and we'll let W represent the weight of the tank in water in pounds. Now, this constant rate of change of 8.35 pounds per gallon tells us that anytime there is some change in volume of water, the weight of the tank in water is going to change so that the ratio of the change in weight to the change in volume is equal to 8.35. Now, this ratio being equal to 8.35, this tells us literally that the change in weight of tank and water in pounds is 8.35 times as large as the corresponding change in volume of water in the tank. So we can use this way of thinking to actually describe how W and V vary together over different intervals. So let's look at some examples. If the volume of water in the tank increases from 13 to 16.5 gallons, what happens to the total weight of tank and water? So if the volume of water in the tank, increases from 13 to 16.5 gallons, then the corresponding change in volume is going to be the final volume in gallons, 16.5, minus 13. And what we know is the change in weight is going to be 8.35 times as large. So change in weight is going to be 8.35 times as large as the change in volume. So this will be equal to 8.35 times 16.5 minus 13. So if we compute that value, so 8.35 we see that this value is equal to 29.225. So this corresponding change in weight is equal to 29.225. So what we can say is, as the volume of water in the tank increases from 13 to 16.5 gallons, the weight of tank and water changes by 29.225 pounds. Let's look at another scenario. Let's imagine that water actually drains from the tank, and the volume of water in the tank changes from 24 to 17.4 gallons. So if this happens, the change in volume of water is going to be equal to the final volume of water, 17.4, minus the initial volume of water. And what we know is that the corresponding change in weight of tank and water is going to be 8.35 times as large. So that change in weight is going to be 8.35 times as large as 17.4 minus 24. We'll notice that 17.4 minus 24 is going to have a negative value since the volume of water decreased. So let's actually compute this change in weight. So this change in weight is negative 55. So negative 55.11. So we can say that over this interval of V, the weight of tank and water decreases by 55.11 pounds. So the weight of water changes by negative 55.11 pounds. Now, one important thing to point out is just because the change in weight and the change in volume are proportional, so just because it's true that the change in weight is proportional to the change in volume, this does not necessarily mean that the weight of water in tank and the volume of water themselves are proportional. So W and V are not necessarily proportional. So let's assume we have a table of values relating V and W, and we'll assume that the tank alone weighs 10 pounds, or when the volume of water is 0 gallons, the weight of the tank and water is 10. Now, if you picked any two pairs of values for V and W, and you computed the ratio of the change in weight to change in volume, that ratio will always be equal to 8.35. No matter what two pairs of values you pick. But if we pick a pair of values, so let's pick this pair of values, and we computed the ratio of W to V, that would be equal to 35.05 divided by 3. And maybe we pick another pair of values. So if we looked at this pair of values and we computed the ratio of W to V, that would be equal to 126.9 divided by 14. And let's actually compute these values. So the first ratio has a value of 11.683. And the second ratio has a value of 9.06, roughly. So we see that the ratios of W to V actually varies if we pick different pairs of values. So in general, just because two quantities' changes are proportional does not mean that the values of the quantities themselves are proportional. So for example, just because if X and Y vary together such that the ratio of changes is some constant number m, this doesn't necessarily mean, actually let's rewrite this as delta y divided by delta x is constant. This does not necessarily mean that the ratio of y to x is constant. So we have to be careful. Just because two quantities vary together at a constant rate of change does not necessarily mean that the quantities' values themselves are actually proportional.